Hello learners, in this lecture we will see what is plasticizers and also what is super plasticizers. So for the plasticizer, we call it as a water reducer because by using the plasticizer, whatever amount of water you are going to use in the concrete, no, that can be bring down. So hence it is called as water reducers. So these are the chemicals when added in the concrete make a coating around the binding particles due to which deflocculation will take place and the particle get dispersed in the water present inside will be free from the lubrication on the surface. So due to the coating particles, so due to the coating, it has to be comma here, yeah, due to the coating particles also start repelling each other, hence the sliding of layers becomes easier and the workability is going to improve. So to put it in a better way, we'll try to see this. See, we have seen that whenever we try to add water into the cement, what will happen, few amount of water will be entrapped, right? So these are my cement particles what I have. So whenever I try to add water, this amount of water will be entrapped and you cannot use that, right? So by using plasticizers, the what plasticizers are going to go, what plasticizers are going to do, so once you put the plasticizers, they are going to do the deflocculation. That means the plasticizers will try to sit on the layer of the cement out on the outer. Let me do it in this way. Yeah, so they are going to sit on the outer layer of the cement particles. As a result of that, what is going to happen, no, they are going to put a force on the cement particle, so they will try to push each cement particle, like that is, this is one cement particle, this is a second cement particle. So this water reducers will try to put a pressure in between them, so that what will happen, they get separated. So once they get separated, whatever water was entrapped here, they're going to come out. You can see it here, right? See, that is called as interparticle repulsive force. They are going to put a repulsive force, and as a result of that, whatever water was entrapped here, they're going to come out. You can see it here, right? So water has come out. So this water which was actually not available, now what has happened, by adding a plasticizer, the water which was actually of no use, I mean, which was actually, yeah, give me a minute. Yeah, so the water which was of no use to me, by using that, whatever water we had it, it is coming out. So this water will help us in what you call binding all the cement particles. So the main idea is that the deflocculation is going to take place, and because of this deflocculation, what will happen, the water will come out, and this water will help us in the lubrication of the cement particles, right? So these are, hence it is called as water reducer. So this is the basic idea of the plasticizer. Next we'll try to see how it functions and all. Yeah, so by using plasticizer, we can improve the workability. Still, we have not even understood what is workability, but in simple work, it's the ability of a concrete to do its work on its own is called as workability. Whenever I pour the concrete, let me do it here, otherwise it becomes difficult to understand. Yeah, so what is workability? Let us say I've taken a concrete here, okay, and I want to pour a concrete into this foundation. So when I try to pour the concrete in this foundation, what should happen, the concrete has to flow easily. Even I should not put any force on the concrete. Whenever I pour the concrete has to go on its own, right? So that is called as workability. That is, it's the ability of a concrete to work on itself. After that, we'll try to use the vibrators and all, that is a different thing, but it's the ability of a concrete flow on its own is called as workability. So how that flowing will happen, when your concrete has enough water content in that, only then it's going to flow like a fluid, right? If there is no water in that, then the concrete is not going to flow here, it's going to stand here only, it's going to create a heap here. So then you have to, with the help of a vibrator, or you have to deploy a person and you have to bring it, I mean, you have to pull it. So I don't want that to happen. So that is why it is written here, by using plasticizer we can improve the workability from 30 mm to 150 mm, or we can reduce the water content up to 30%. So how this 30 mm and 150 mm we'll try to understand when we do the slump test on the concrete. So 30 mm and 150 mm is the, it's the ability of the concrete. Whenever you do the slump test and all, we'll try to see that. And along with that, what plasticizer can do for us, it can reduce the water content, right? Let us say you are using some, 100 liters of water for rough thing I'm explaining. Okay, so now by using the plasticizer, what will happen, instead of using 100 liters of water, you can use 85 liters of the water. So that 15% you are going to reduce by the use of the plasticizer, right? Now coming to the example part, you can use lignosulfates as a plasticizer, you can use carbohydrates as a plasticizer, and you can use carboxylic acid as a plasticizer. So these are the different plasticizers. With the help of this, you can prepare a plasticizer that is available in the market, and after that, we'll try to use them. Yeah. So you can see it here, Cera Plus 200 superior concrete water reducing agent is written here. Then this is one of the famous brand. Even Cera Plus is also a famous brand. Even Complex, yeah, this is Complex, right? Yeah, this is also a famous brand which is available in the market. Yeah. So again, coming to the theory part, the organic substance or the combination of organic and inorganic substance which allow a reduction in the water content for the given workability or give higher workability at the same water content are termed as plasticizing admixture. If you want to put it in a better way, you can try to write this. Water reducing admixtures are used to reduce the quantity of the mixing water required to produce the concrete of a certain slump and reduce the water cement ratio, reduce the cement content, or to increase the slump is that like how much amount of water has to be added, how much flowable my concrete has to be, so that we try to measure with the help of a slump. Plasticizers are used in the amount of 0.1 to 0.4% by the weight of the cement. Again, plasticizer, we have certain dosages, right? Based on that dosages, we are going to make use of the plasticizer. So at this dosages, at a constant workability, the reduction in the mixing water is expected to be 5 to 15%. So if you put a plasticizer in the dosage of 0.1 to 0.4%, up to 15% reduction in the water content can be done. So based on a requirement, how much amount of water I need to reduce based on my mix design, we'll try to make use of this plasticizer. Yeah. So you can see with a very beautiful image here what will happen actually. So what is the purpose of adding plasticizer? First is to achieve higher strength by decreasing the water cement ratio. So actually what happens when adding more and more water in the concrete, what will happen? Let me write it here. If your water content increases in the cement, okay, then the strength of the cement is going to come down. That is, the strength of the concrete is going to come down. So but you want to achieve more strength, so this is not possible. If you want to increase the more strength, then your water content should be done, water content should be less. If water content is less, then workability will not happen, your concrete will not be flowable, right? So in order to take a effect of both, I want strength also, and also I want good amount of water in my concrete. Then what we are going to do, we'll make use of the plasticizer. So to achieve higher strength by decreasing the water cement ratio, we can use the plasticizer. The second is to achieve the same workability by decrease the cement content, so has to reduce the heat of hydration in the mass concrete. And also the last thing is that to increase the workability, so has to ease the placing in inaccessible locations, we try to make use of the plasticizer. You can see it here. If you don't add a plasticizer, this is how your concrete is going to look. So this test we do with help of a slump cone test that we'll try to see in the chapter 2, right? So it is very stiff. Now imagine you're placing a concrete something like this in the foundation. I'll draw a foundation here. Now what will happen? The concrete will remain in this way only. Now again you have to deploy a person, you have to use a vibrator, only then your concrete will be flowable. But look here, let us say you're pouring this type of concrete in a foundation. So the concrete on itself is having enough workability, or let us say enough water in it, so that it is easily flowable and every part of the foundation will be covered, right? So this will happen when you try to make use of a plasticizer. So it's written here, workable concrete mix, and it is too stiff to work with. So with the help of plasticizer, we can increase the workability, or we can even decrease the water content for the same workability. Yeah. But again, using plasticizer depends on the condition, whether really you want to use a plasticizer or not. Again, for the same thing what I've explained, if you're doing a normal construction and all, it's plasticizers and all are not important for us. We go with normal water, cement, sand and all. But again, for a very high rise building, when you want to achieve more strength but you want to reduce the water content, in that case we try to go with the plasticizer based on our requirement. Yeah. So again, you can try to go through this. I already explained it, but if you want to put in your own words and if you want to understand more, so actually, this is how the principle about plasticizer is. This is how it works. You can go through this and understand that. Okay, yeah, the same thing is written here. You can go through that. Yeah, again, so further plasticizers what we have, no, they're again classified as the mid-range water reducers, and then we have another one that is a, yeah, yeah, they are classified as normal water reducer and mid-range water reducer. So if you want to go through this, you can go through this, but whatever I've explanation I have done, that is enough. but still if you want to write more things about this, you can go for that. Further you can tell plasticizers are classified in under normal water reducer, where your water content can be reduced up to 5 to 10%. And if you want to reduce it by 10 to 15%, then you can go with a mid-range water reducer. And for the examples are this thing, that is a hydroxylated carboxylic acid, a derivative of lignosulfonic acids, and so on, right? And coming to all these things, these are the advantages of using the plasticizer. You can try to note it down. Yeah. So the next what we have is a super plasticizer. So right now we had seen plasticizers, right? We had seen plasticizer. Now we are looking into super plasticizer, which is called as high range water reducer. So it's something like, you can remember, see, we have Kunal Pandya and Hardik Pandya, right? So they're brothers. In the same way, super plasticizers and plasticizers are like brother. And we know that Hardik Pandya always perform better compared to the Kunal Pandya. So always super plasticizer will perform better compared to the normal plasticizer. The principle is same. Again, the principle is to reduce the water content to increase the workability. But again, for a very less water cement ratio, if you want more and more workability, then we try to make use of the super plasticizer. That's it. This is a basic principle behind them. That's it, right? Yeah. Now we'll try to see. So these are called as modified form of plasticizers. They are functionally similar to the plasticizer, as I mentioned, but they're chemically different. Chemical different means the certain compounds what to try to add in the plasticizer, here the percentage of that will try to change. So the chemically different with modified properties as compared to the plasticizer. Super plasticizers can reduce the water content up to 30%, right? So plasticizer can reduce the water content up to 10 to 15% maximum. But even beyond that, if you want to reduce the water content, I mean, if you want to, yeah, yeah, even if you want to reduce the water content up to 30%, so and you want more and more workability, in that case you can go with a super plasticizer, right? So again, the main important thing is if it is in excess, right? If it is an access, it will start behaving like a retarder. So always whenever we try to make use of the admixtures, there are certain percentage to be added. Based on that we have to add it. Okay, just because they are giving certain properties, that doesn't mean that we'll add them in access. So all these things require a careful analysis, a very good mixed design, and after that we try to add all these things. Now again, coming to the example, modified lignosulfates are the example for the super plasticizer. Sulfonated melamine formaldehyde is the example for the super plasticizer. Sulfonated naphthalene formaldehyde is the example for a plasticizers, right? Yeah. So you can see it here, no? What is written? Super build is the name of a company. High quality water reducer super plasticizers are written. So this is a place where it is manufactured. So there are a lot of companies, the local people also. I mean, the local, what you call, you get local people also, those are into this business of making plasticizers. So wherever you want, you can give order and you can get it, right? This is how it has to be done. Now coming to the purpose is very same like we got in the plasticizer. First is to improve the cohesiveness and thereby reducing the segregation of the bleeding. We'll try to understand what is segregation and bleeding in the chapter 2. Next is to increase the workability and pumpability without increasing the water cement ratio. We already seen for the very same water cement ratio, I want to increase the workability, right? In that case, we go with the super plasticizer to reduce the heat of hydration and drying shrinkage by reducing the cement content. How this cement content will be reduced? Because this is water by cement ratio, right? If my water by cement ratio, if it is less, that means cement content is also less. So in this way you can try to do that. To increase the strength, to increase strength by reducing the water cement ratio, maintaining the same workability. We already seen what is workability. And in order to get a very good workability, you need to have more water. But if I add more water, then the strength is going to come down. In that case, we try to make use of super plasticizers so that my workability is also achieved and I'm not adding more water, right? In that case, we can try to make use of super plasticizer. Next is to reduce the permeability and improve the durability by reducing the water cement ratio. It's for a very same reason. If your water cement ratio is good, then strength achievement will be good and your durability also increases, right? These are the different purposes where the super plasticizers are used. Yeah. Again, under this we have this common high range water reducer. Again, you can go through this. These are called as super plasticizers. Again, these are the example for that. And coming to the effect of the super plasticizer, what is going to happen if you're using more and more super plasticizer that is written here, we can go through it. It is to be noted that dramatic improvement in the workability is not showing up when plasticizers or super plasticizers are added to a very stiff or what is called a zero slump. Okay, that means if you're adding more and more plasticizer for the fresh concrete, then it will not show that effect. That is the first thing. What is zero slump? We'll see it in the second chapter. It's very difficult to understand here, right? Other than that, yeah, these things are written here. You can go through that. So the basic understanding is clear. I hope the basic understanding is clear. So these are the effect on the fresh concrete, what will happen. Yeah, yeah, even you can go through this advantages of the using super plasticizers. Okay, it's a very same thing what I've explained, but they put it in terms of point. You can go through this. Yeah, done. So I hope these things are clear about the plasticizers and super plasticizers. uh, so we'll see you back in the next lecture. Thank you.